we can look at a slightly different problem here. So, this says that there is a spherical water droplet of diameter 1 millimeter. So, it possibly helps to draw it as a droplet which has a diameter of 1 millimeter. It is subjected to a constant aerodynamic force. So, this is essentially what would happen if you have a droplet and some air is pushing this droplet, and since the droplet is not a solid, it is a liquid, it would deform. So, air is creating an aerodynamic force on it for a short time interval, during which this droplet deforms into a shape which looks like a disc. So, what happens is this forms a disc-like shape. So, let us draw a disc. Okay, it looks like a disc with a diameter of 2 mm. So, now the diameter of this disc has changed. Of course, another example of this would be like if you are trying to make chapatis and you have, like, say you make a nice ball, let us say it has a diameter of 1 mm, and then you press it and it becomes a disc-like shape. So, now it has a bigger diameter, it has become thin in one direction and it has become bigger in the other direction. And what it said is the droplet just changes the shape but does not move. We are just assuming that this is the case. Once the force is cut off, the droplet regains the spherical shape. So, after the force is removed, once again it becomes spherical. Of course, that is not immediately relevant, but what we are trying to do is calculate the work done by the aerodynamic force in going from this shape to the other. That is essentially what we want to find out. So, once force is cut off, it will come back to whatever it was originally. We are told that we can neglect viscous forces and other stuff. So, we have this liquid, it is initially in the shape of a sphere. So, if I have a diameter of 1 mm, I can calculate what is the volume of the sphere. So, this would be the volume of the sphere. So, that is 5 into 1 mm is 10 power 1 in 10 power minus 3 meters, the whole cube, divided by 6. That is 0.523 into, I have 10 power minus 3 cube. So, that becomes 10 power minus 9 meter cube. So, this is the initial volume of this sphere. So, the final volume, let me call it as to be some V2, would be the volume of this disc. This is a cylindrical disc. So, its volume would be given as pi r square into height, or pi d square by 4 into height. And we have a liquid here. Liquids are what are called incompressible, which means that the volume cannot change. If you take an amount of liquid, you can change it into different shapes, but the volume of all of the shapes should be the same. So, V2 should be equal to V1, and that is equal to this value. But what I can also do is, I can find out the height of this disc in this direction, because I know this. So, writing this again here, the new diameter, this is D2, this is D1, the new diameter is 2 mm. So, which means pi by 4 into 2 in 10 power minus 3 square times height is equal to this value. I am going to write this minus 9 as minus 6 into minus 3, because I can cancel out this minus 6 portion when I equate these, and I want to find out the value of height. So, this goes with this part. I have 2 squared is 4, 4 and 4 get cancelled. So, I have pi into h is equal to whatever is left here. So, h is this value by pi. So, I have 0.523 divided by 3.1415, that is 0.16 in 10 power minus 3. Yeah. So, I am left with a height for this droplet of this kind. So, what we have here is deformation of a surface. So, in these kind of cases, the work which is done is against surface tension. So, the work which happens is because the surface area is changing, and we can see how the surface area is changing. So, initially this droplet had a spherical shape. Its initial surface area, we can call that as A1, is the surface area of a sphere, which is 4 pi r square, or essentially pi d square. So, that is pi into, it had a diameter of 1 mm. So, that is 1 into 10 power minus 6 . This was its initial area. We can find out its final area. The final area is essentially the area of the cylindrical disc. Okay. So, the area of the cylindrical disc is, we have the two edges, the two caps. So, it is pi r square on the top, pi r square below, and then we have the area of the flank of the cylinder, which is essentially so we have the area of the surface sides of the cylinder. So, we can find out the value of this as well. So, this is 2 into pi into R2 is 2 mm. Sorry? This is correct. Sorry, the value of D2 is 2 mm. So, value of R2, okay. So, D2 is 2 mm. So, R2 is 2 by 2, which is 1 mm. So, that is being pointed out. So, we have R2 as 1, okay, and then we have pi into D2, which is 2 in 10 power minus 3 into height, which is we just found as 0.16. So, this whole thing is in meter square. So, this is 2 pi in 10 power minus 6. Okay, I am going to take 10 power minus 6 out. So, this is 2 pi plus 2 into 0.16 pi. So, that is 2 plus so this is 6.38 into 10 power minus 6 meter square. So, what we see is that the initial area was 3.14 in 10 power minus 6 meter square, final area is 6.38 in 10 power minus 6 meter square. So, there is a difference in area of, so that is 7.28, so that is right. So, we have 7.28 minus 3.14, which is about 4.14. in 10 power minus 6 meter square is the change in area. So, the work interaction due to surface tension is what we have here. So, work interaction due to surface tension we wrote earlier is given by the surface tension into change in area. So, if you have for example a droplet or a bubble, if you increase its area, you are doing work against the surface tension, you are increasing the energy of this droplet or a bubble, and the work interaction for this droplet would be negative, and the work interaction for the force which is doing this work would be positive. So, here the surface tension work for the droplet would be negative. For the aerodynamic force, if I have a force from outside which is making this deform into this shape, so it goes from this so for the droplet itself, this force is doing negative work. For the forces outside, which is the aerodynamic force, this work interaction would be positive. Okay. So, the general formula would look like this. So, the work for the aerodynamic force would be positive. So, we need to know the value of the surface tension. So, the surface tension of water, which we did not give in the question, but it is should have been there, is generally about 72 millinewton per meter. So, that is 0.072 Newton per meter into 4.14 into 10 power minus 6 meter square. So, that is 0.298 into 10 power minus 6 Newton meter into meter square is Newton meter, which is essentially joule. So, we see that it is about 0.298 microjoule, small amount of work in order to change the shape of a small droplet. So, this work is positive for the aerodynamic force, and work interaction for the droplet is essentially this, which would be minus